Hello everyone and welcome back. So in the previous lecture we learned what is Stokes theorem. So Stokes theorem is a relation between line integral and surface integral. Then after that we did some examples. Now in this particular lecture we will do some more examples and very important examples. So kindly go through this video line by line and practice, then it will be very helpful. Okay, so let's begin. Now see what is the first problem. Given the vector field, one vector function is given, capital F bar, which is yi cap minus xj cap and then what, zk cap. What we have to do, we have to verify Stokes theorem. So when it is asked to verify, that means we have to find left hand side and right hand side separately. For the hemispherical surface, x square plus y square plus z square equals to what, a square, and z is greater than equals to 0. So hemispherical surface means it's not the whole sphere. We have to take the hemisphere. Hemisphere means, suppose we are talking about this part. Okay, this half of the sphere. Okay, so limit will a little bit different, but other things are all same. Okay, now what is Stokes theorem? By Stokes theorem, we have closed integration over C F then dr bar. So you can write F bar and dr bar, or if you skip then you don't write, is equals to double integration over S. Now it is nebula cross F dot n cap what, ds. So we have to find left hand side and then again right hand side individually. So for left hand side we will find later on. Let us find the right hand side, because the right hand side is right hand side involve a little bit more calculation. Okay. Now let us find nebula cross F first. Nebula cross F. So how to write? I cap, j cap, k cap, del x, del y, and then what, del z, del z, and f is y minus x and then what, z. Now you have to split it. So how much, del y of z is 0, again del z of minus x is 0, so it's 0, minus j into, now this row, this column vanish, again c is 0 minus 0, so this is also 0, and finally k cap into row column vanish. Okay, so minus 1 then minus 1, so you'll get minus 2k, means 2k cap. This is our nebula bar cross F bar. Nebula cross what, k. So that you have to find first. Next, what to find? We have to find a nebula F. F means the surface. So this is equals to nebula. Here our surface is what? Hemispherical surface, x square plus y square plus z square. If you want, you can write minus a square also. So how much it is? This is equals to I del x plus j del y plus k del z. With this what we have, x square plus y square plus z square, then minus a square. So when you differentiate it, only del x, when you do I del x, so with del x just you have to differentiate x square, because all the other terms will vanish. So it is I into del x of x square is how much, twice x, then in the same way j twice y, k what, twice z. So this is our delta f or nebula f. Now we have to find the unit vector, the unit outward drawn normal, which is n cap. So n cap means this one. At any point if we draw this vector, then the unit outward drawn normal is called what, n cap. Now what is the formula for n cap? This is nebula f by modulus of nebula f. So in surface integral you get this particular formula, or maybe in some other vector calculus lecture also you will get this particular formula. N cap, how to find n cap? Vector by its modulus. So nebula f divided by modulus nebula f. So nebula f just now we have, right, twice x I cap, twice y j cap, twice z k cap, divided by, same thing we have to write within modulus sign, twice y j cap plus twice z k. So if you calculate it, what you will get after calculation? 2 cancel out, xi yj plus z k, okay, divided by, here to 2 cancel, and modulus of x I cap y j cap z k cap is nothing but root over x square plus y square plus z square. So you see in the question, x square plus y square plus z square equal to how much? A square. So if you put a square, so root over a square is how much? A. So finally we have xi yj zk divided by how much? A. Okay, so we already find nebula cross f, and here we got n cap. Now we can now to find the left hand side, right hand side, what you have to find now? N cap dot what? K cap. So our n cap is x I cap y j cap plus z k cap divided by a dot k cap. So it will be only k dot k, right? Other two term will be 0 because I cap dot k cap is 0, j cap dot k cap is also 0. So you have only k dot k. K dot k is what? 1. So how much you will have? Z by a. Okay. Now in from surface integral, what is the formula for ds? ds we can write dx dy. So if it is x and y, what we have to write in the denominator? N cap dot, if it is x and y, then we have to write k cap, right? dx dy by n cap dot k cap. If you write dy dz, then it will be n cap dot I cap. And if you write dx dz, then it will be n cap dot j cap. So this is equals to dx dy. This formula will get in surface integral. Then n cap dot k cap is how much? Z by a. Okay, z by a. So it's a by z dx dy. Now let us go to the right hand side. Double integration over s nebula cross f dot n cap ds. So this is equals to double integration over s. So what is nebula cross f? It is minus 2 k cap. Okay, minus 2 k cap. Then dot n cap. N cap we have how much? N cap is yes. N cap is xi yj plus zk divided by a, and then in place of ds we will write a by z dx dy. So first a cancel out. Okay, a will cancel out. Now for the remaining calculation, what you will do? What is xi cap plus yj cap plus zk cap? Xi cap plus yj cap plus zk cap. This is nothing but, you see, xi cap plus yj cap. Okay. Now first you have to find the dot product of these two. Here you see we have k cap, and here this is k cap. Other two term will remain 0. So double integration over s. So minus 2 is constant. So this into this, right? K cap dot k cap. So it will be minus 2 z. Here a is already cancel out. So we have 1 by z dx dy. Okay. Then now z is also cancel out. So minus 2 double integration over s dx dy. So it's a very simple one now. all the other term is cancel out. Now how to integrate it? Okay, how will integrate it? Only dx and dy. For that, so let us take the substitution since it's only x and y. So you can choose like this: x equal to r cos theta, and then y equals to what? R sin theta. You can take the polar coordinate, polar transformation. So already I told that if it is x equal to r cos theta, y equal to r sin theta, then what is the Jacobian? Only r. Okay, Jacobian is r. So in place of dx dy, it will be r dr and d theta. In the last lecture of Gauss divergence theorem, you see how to find the Jacobian. And already these things we already know, that if x equal to r cos theta and y equal to r sin theta, then if in Cartesian form the area is dx and dy, then in polar form it will be r dr d theta. So let us put this in this particular relation. So this is equals to, now it will be minus 2 will be outside. Okay, now what is the limit of r and theta? R and theta. So r equals to, before writing the limit, just write one more line, double integration over s. 2 is outside. In place of dx dy, what will write? R dr and then what? D theta. So minus 2 into r equals to 0 to a, because the radius is how much? Radius is a. You just look at the circle. Yes, I'm talking about this one. It's what? A square. Okay, a square. Then what will be theta? To make a circle, you will have r dr here, and the limit of theta will be theta equals to 0 to what? 2 pi. Because see, when we make a hemisphere, first you have to take this radius which is 0 to a. Okay, then you have to rotate it. How will rotate? Like this you will rotate. So theta will be how much? 0 to twice pi. Then you will get the, if you rotate it 180 degree, then you will get a hemisphere. So it's d theta. So minus 2 outside, r square by 2 between the limit 0 to a, theta between the limit 0 to 2 pi. So these two cancel out, minus 2a square, and from here you will get 2 pi. Okay, so finally you will have minus 4 pi a square. 4, not 4. Already these two is cancelled out, right? Okay, a square. So minus 2 pi a square. This is our left hand side. Now we'll find the right hand side. So let us find the right hand side, which is, let us draw the hemisphere again. So this was the hemisphere. For the right hand side is a line integral, no? So we'll only take this circle. So the equation of the hemisphere is what? X square plus y square plus z square equal to a square. So this particular equation of this particular circle will be what? X square plus y square equal to how much? A square. And since this is in xy plane, so z will be equals to how much? 0. Okay. So now let us do the calculation on the circle. On the circle, x square plus y square equal to a square, z equals to how much? 0. This is for the xy plane. In the xy plane, okay, see, this is a two-dimensional plane, xy plane. So for this, here in this particular plane, z will become what? 0. So what is our left hand side in Stokes theorem? F dot what? dr. So this is equals to integration over c. Then f is our yi, then minus xj plus zk. Okay, and then with this what we have? dr. So dr we can write dx I cap plus dy j cap plus dz k cap. Okay, so this is equals to integration over c. If you find the dot product, it will be your y dx minus x dy. Okay, x dy. And since z equals to 0, no, so we no need to write this term also, because for z equals to 0, the last term will vanish. Now, how to integrate this? So again, we have to take the transformation. Let x equal to, now, what is the right hand side? For the circle, we have a, na? So let us write like this, a cos theta, and y equals to what? A sin theta. X equal to a cos theta and y equals to what? A sin theta. So if you differentiate this, because you have to transform all the variable in one term, so our dy will be a cos theta and d theta. Now let us do the integration. Integration over c f, no need to write this bar because we haven't used, f dot d is equal to how much? So if you put all these values here, it will be integration y, no, y is how much? Y is a sin theta, and dx will be how much? Dx, our dx will be minus a sin theta d theta. So minus a sin theta d theta, then minus, first one is our y, no, y is a sin theta, okay, then x is a cos theta, and then again dy is a cos theta d theta. So after putting this value, minus a square you can take outside, okay, theta, limit of theta will be what? 0 to 2 pi. For the circle, 360 degree, theta equal to 0 to 2 pi. If you take minus a square outside, then we have sin square theta plus cos square theta d theta. So sin square theta plus cos square theta is how much? 1. So minus a square theta equal to 0 to 2 pi d theta. So it's simple integration now. So minus a square integration d theta is theta between the limit 0 to 2 pi. So after putting the limit, you will get minus 2 pi a square. Now see, exactly same answer you have in this part, no? See, same. Here also you have minus 2a square. Here also you see minus 2a square. So that means what? Stokes theorem is verified. So the problem is very interesting. Yeah, a little bit lengthy because I am going very slow. So once you do the problem, then you'll see within 4 to 5 minutes you can do the sums. Now in the same way, you try this problem, exactly same problem. Okay, only here on the right hand side you see one a. So in the last problem, this term is a square, but here it is a. And in the last problem we have what? Hemisphere, and it is upper half of the surface of the sphere. The meaning is same. So if we draw a sphere like this, suppose this is the sphere. So upper half means we are talking about this upper part, means again the upper hemisphere. So in the same way you do, only at the final stage, you see the last problem. See, here we have taken a, na? Why it is a? Because of the circle. Because this in this circle we have a. So for this particular problem, when you do the left hand side, so you will take, let x equal to 1 cos theta, means cos theta, and y equals to what? A sin theta, means only sin theta. Other things are almost same. All the terms are same. When you find left hand side and right hand side, your left hand side will be after calculation. If you do the calculation, left hand side is what? Double integration over s, and then nebula cross f dot n cap ds. So just like the problem one, it is exactly same. You just proceed. So after calculation, this is your pi. So your left side is also what? Left hand side is also f dot dr is also pi. So this part you will get. Okay. So kindly do the problem. If you stuck somewhere, then you write in comment box. So I'll do one more video to solve this. But if you understand the first problem, then it's very, very easy. Okay. Now it's a different kind of problem. This is not verify. Evaluate by Stokes theorem. So apply Stokes theorem, we have to find this value. So when you see this particular value, no, is what left hand side integration over C f bar dot d r bar type. So we have to write the Stokes theorem, and when you find the right hand side, then you'll get the answer. Okay, so by Stokes theorem, we have integration over C f dot dr is equals to what? Double integration over S nebula cross f dot n cap ds. Okay, so first we have to find nebula cross f. So same I j k del del x del del y, then del del z, and here what to write? We have to write what is the function here? Yz, no, and the function is okay, so it's yz zx and then y xy. So just split it. Okay, so I cap into C, del del y of this and del del x of this. So you calculate it. After calculation, no, you'll get 0. So since this term is 0, no need to find all the other terms. No need to find n cap, because for n cap we have to find the nebula f by modulus of nebula f. But when we expand this determinant, so exactly 0 will get. So our answer is how much? Directly 0. So this is a very simple problem. So in the left hand side, it should be yz dx plus zx dy, zx dy, and then plus xy dz equals to how much? 0. Because this part, no, this part is 0. So it's a very simple problem. Let us take one more. Okay, so evaluate. So this is also evaluate, not verification. Evaluate closed integration over C f dot dr bar. F bar is something else. So by Stokes theorem, don't write in short form. We have integration over C f dot dr bar is equals to double integration over S nebula cross f dot n cap ds. So what to find? So first you find nebula cross f. So this thing you find, because otherwise our video will be too long. I j k del del x del del y then del del z. Now here f is minus y square x and then what? Z square, right? Minus y square x and then z square. So after splitting you will get 1 plus twice y k cap. This much you will get. But here, since this is not 0, now we have to find the value of n cap. So for n cap, what to find? We have to find nebula f. So nebula, our f is how much? F is this plane, no? This is the plane. The curve is the intersection of this plane and the cylinder. So let us find for the plane, means y plus z. If you write, then minus 2 also. So nebula is what? I del del x, z del del y, I del del x plus j del del y, k del del z. With this what we have? Y plus z minus 2. So when you find, you will get how much? This to 0, j cap plus what? K cap. Only this will come. Now we'll find n cap. So value of n cap is how much? Nebula f by modulus nebula f. So it's j plus k divided by modulus j plus k. So this is nothing but j plus k, which is root over 1 plus 1 means root 2. Okay, then what to find? Then we have to find n cap dot k cap, right? N cap dot k cap is how much? Our n cap is j plus k by root 2 dot k cap. So only k cap, with k cap we'll get. So we'll get 1 by root 2. So this is the value of what? N cap dot k cap. Now what to find? We have to find ds. ds is dx dy divided by n cap dot k cap. So dx dy, so what is n cap dot k cap? N cap dot k cap is 1 by root 2. So you have root 2 dx dy. Now let us put all this in this left hand side, in this left hand side. So therefore double integration over s nebula cross f dot n cap ds. So double integration over s, what is our nebula cross f? 1 plus twice y, then dot n cap, no, our n cap is j plus k by root 2, and then ds is root 2 dx dy. All problems are of similar kind. So there should be one more term, k will be there, right? K. Okay. So 1 minute. One plus twice y k, then dot this one. So only this k dot k will come. So we can write root 2 outside, double integration over s. What we have? There is one, oh, this root 2 will cancel out. This root 2 will not come. So how much you will get? K dot k, no. So it will be 1 plus twice y and then dx dy. So after that, you all know we have to substitute x equals to what will take? R cos theta, and then y equals to what? R sin theta. Let us put it. Double integration, limit of r and theta will put later on. 1 plus 2y, y is r cos theta, then dx and dy. In place of dx dy, what will get? Dx and dy, it will be r dr d theta. So r dr d theta. Okay, r dr d theta. So now what will be the limit of r and theta? Limit of r and theta. Can we separate them? Because cos theta is with this, no? So we have to integrate with respect to r first. So r equals to 0 to 1, nah? Because the radius is, let me see. Yes. Okay, I am talking about this one. This is important. This is 1. So limit is 0 to 1. 0 to 1. And then what is the limit of theta? Limit of theta will be, since it's a circle, 0 to how much? 2 pi. So let us multiply it. R plus 2r square cos theta dr d theta. So first, since r involved theta, so we have to integrate it with respect to r first. So if we integrate it, it's r square by 2 plus 2 into r cube by 3 cos theta, and then d theta between the limit 0 to 1. Okay, 0 to 1. Then I made one mistake, I guess. Yes, this is y, no? So y is r sin theta. Sorry, this should be sin theta. This is also sin theta. Okay, this term is also sin theta. Kindly correct it. Okay. So after putting the limit, what you will get? Theta equals to 0 to 2 pi. So when you put the limit, you will get half plus 2 by 3 sin theta, and then what? D theta. And finally we have to integrate it with respect to theta. So it will be our half, then integration sin theta is minus cos theta 2 by 3 cos theta between the limit 0 to 2 pi. So you put the limit, and after putting the limit, you will get how much? Pi. So this is the answer. Okay. So only a simple, in some steps you have some simple calculation, but in general is what? The calculation is very, very easy. Okay. So this is the last problem. So this problem you try yourself, evaluate this by Stokes theorem. where f bar is given, in the same way you try, but it is given that the boundary of the triangle of the vertices. So 0, 0, 0, 1, 0, 0, and then what? 1, 1, 0. Now, how to write the limit of the function, that I'll explain. Other thing you can easily do by yourself. Okay, so see, here if you observe this vertices, no, observe these vertices, then you will notice one thing. In all the cases, no, z is 0. Okay, so it's z equal to 0. So z equal to 0 means what? It is xy plane. Okay, xy plane. So if it is xy plane, then this is nothing but n cap equals to how much? K cap. Because in Z, what is the equation of z plane? In z plane means it's a xy plane only, you will get k cap, exactly like the previous problem. In last problem also you will see that we have only k cap. Then if you do the remaining calculation, first you find nebula cross f. So after finding nebula here, f means the components are y square, x square, and then minus x plus z. So if you do this, how much you will get? You will get j 2 into x minus y, and then what? K cap. So this is nebula cross f. So when you write the formula, double integration of, I am not writing in detail. So if you just write in detail, dot n cap ds. Now see, nebula cross f is this one, and n cap what we have? K cap. N cap means how much? K cap. And then we have to find ds. ds is dx dy by what? N cap dot k cap. So here n cap is also k cap. So k dot k is how much? 1. So you will get only dx and dy. So what will be the limit? You have to put the limit, right? So what will be the limit? Here, without transforming also, you can do the problem, because when you do the left hand side, no, double integration over s nebula cross f dot n cap. After doing nebula cross n dot n cap, you will get 2 into x minus y, and in place of ds you will get dx and then dy. So all the terms are in terms of x and y. So if you want to do, then you can do it directly, like the limit of x is 0 to 1, and the limit of y will be how much? Y will be 0 to x. Okay, 0 to x. How you know that this is 0 to x? Because if we take the points, no, see here x is how much? X is 0 to 1, and when you take the limit of y, how to find the limit of y? When you draw the triangle, this triangle 0, 0, 0, this point is 0, 0, 0, then 1, 0, 0 is this point, and then 1, 1, 0, like this, you'll get the triangle, no? So the limit of x is 0 to 1, and see how to find the limit of y. This is nothing but a straight line passing to the origin. So equation of straight line passing to the origin is what? Y equal to x. So limit, here y equal to how much? Here y equal to 0, and upper curve is y equal to x. So that's why limit of x is limit of y is 0 to x, and then 2 into x minus y dx dy. So what you have to do, first you have to integrate this with respect to y, because y involve x. So x equal to 0 to 1, 2 into xy minus y square by 2 between the limit 0 to x dx. Okay, and finally after putting the limit, what will get? X equal to 0 to 1, if you put the limit, 2 into x square minus x square by 2 dx. So all the terms are in terms of x. So finally you integrate this part and put the limit, you will get the answer as 1 by 3. Okay, so similar kind, only in the last part, no, we have not substituted. But if you want to substitute it, let x equal to r is 1 cos theta, and y equals to, or r cos theta, y equal to r sin theta, then also you'll get the same answer. You try it in two different way, you'll see that the result will be same. Okay, So I hope this particular video clarifies all the doubts of different kind of problems of Stokes theorem. So you practice this problem, and if possible you do some more problems from different books, so that will help you. So thank you very much for watching the video till now. So I hope all your doubts will be clear. So if you like my video, kindly subscribe and share with your friends. Thank you once again.